Hello friends, in my previous video I have already discussed about the Barkhausen criteria and with the help of the noise in positive feedback with application of the Barkhausen criteria how we can generate oscillations. About that topic I have discussed in detail. Now in this video I am going to discuss about the phase shift oscillator, which is one of the very important oscillator in real time. Okay, so let us discuss. So our today's discussion topic is phase shift. See, I have drawn here one general phase shift oscillator. This block is basically one amplifier block. Okay, clear, with gain minus k. Okay, let us assume that the gain of this amplifier block is minus k. What the minus symbol indicates? Minus symbol indicates that this amplifier is basically one inverting amplifier. So suppose we give input signal in such a way, then we will get output signal as amplified version, but obviously in between input and output there is 180-degree phase shift. To denote the 180-degree phase shift, this minus sign is there. Clear? Now what we do, we just give this inverted output in this network. Okay, see here, this network is basically feedback network. Why? Because oscillator is made up of two components. One is basic amplifier block, another one is feedback block. This is, I told you, basic amplifier block with gain minus k, and obviously so that it will be the feedback network. Clear? See here, feedback network is made up of capacitor and resistor, combination of capacitor and resistor. Sorry, as I mentioned in my previous video, that if the basic amplifier block is inverting amplifier, then in that case the feedback network also should provide 180-degree phase shift, so that here in basic amplifier block 180-degree and in the feedback block 180-degree, total 180-degree plus 180-degree 360-degree phase shift will be there. So to make 180-degree phase shift by a feedback network, obviously inductor or capacitor should be component of that feedback network, because if the feedback network is purely resistive, we cannot get any phase shift in between input and output. We know from the basic concept in electronics. So that obviously I told you that in oscillator, in feedback network, if we apply basic amplifier block as inverting amplifier, then obviously we have to make the feedback network with the help of capacitor, inductor and resistor. Resistor may be there or may not be there, but capacitor or inductor must be there in that feedback network to provide 180-degree phase shift, because purely resistive network cannot provide phase shift. Clear? So from here also you can clearly see that the feedback network consists of resistor and capacitor. Now to sustain oscillation at a certain frequency, at a particular frequency and with a particular amplitude, what are the two criteria must be satisfied? One is mod of a times beta, that is magnitude of multiplication of basic amplifier gain, and feedback gain should be equal to 1, and one complete loop rotation, and in one complete loop rotation the phase shift should be 0-degree or 360-degree or multiple of 360-degree. That is, angle of A beta should be how much? 360-degree. Clear? This thing you know from the basic concept of oscillator. So basically, as I mentioned, this is basic amplifier block which is inverting in nature. So here 180-degree phase shift is already taking place. So obviously rest 180-degree phase shift must be done by this circuit. Then only after a complete loop rotation there will be 360-degree phase shift, because 180-degree here and 180-degree here, total 360-degree. Clear? So basically this RC coupled circuit, this RC network should provide 180-degree phase shift. How it provides 180-degree phase shift I will discuss in detail. And this criteria, that is mod of A beta equal to 1, what it indicates? It indicates that what is the mod of A beta equal to 1 means what? Mod of A equal to 1 by mod of beta. Clear? This thing only we can say from the equation na. So what is mod of A? Mod of A is mod of minus k, that means k, because mod of minus x is equal to x, only positive value comes out. So k is equal to 1 by mod beta. This we are getting from the first equation. What this indicates? It indicates that the basic amplifier gain, magnitude of the basic amplifier gain should be equal to 1 by magnitude of the transfer function, is equal to 1 by magnitude of the transfer function of this feedback network at the certain frequency in which we want to make the oscillation, or at oscillation frequency. Okay, so I will repeat again. So this k equal to 1 by beta indicates that to make certain oscillation, the magnitude of the basic amplifier block, that is the magnitude of the gain of the basic amplifier block, that is k equal to 1 by magnitude of the transfer function of this feedback network at the oscillation frequency. Clear? In this way we can satisfy the first equation. Now we have to satisfy the second equation, that is angle AB equal to 360 degree. That means somehow we have to design the circuit in such a way that is the feedback network should provide 180 degree phase shift. Clear? So how this happens, let us check. So see, this is one capacitor and resistor connected in series. We are taking the output voltage across the resistor and we are providing input voltage here. So what is the impedance of the whole circuit? Z equal to R plus 1 by j omega c, as you know. So we can write this in this form also, Z equal to R minus j by omega c, because 1 by j equal to minus j. Clear? So if we take the magnitude of this whole impedance, we can get, or equivalent impedance. So magnitude of the equivalent impedance equal to root over of R square plus 1 by omega square plus c square. Now we take the angle of this complex number. See, what is the rule to calculate the angle? Z equal to, let us assume, x plus iy. Then if this z is situated in the first quadrant, then the angle is equal to tan inverse y by x. If z is situated in the second quadrant, then argument is pi minus tan inverse mod of y by x. If z is situated in third quadrant, then the argument is minus of pi plus tan inverse mod of y by x. And if z is situated in the fourth quadrant, then argument is minus of tan inverse y by x. See here, z is equal to x plus iy, x is r, and y is equal to minus of 1 by omega c. That means obviously the z is situated in fourth quadrant. So the magnitude is minus of tan inverse mod of y by x. That's what I have written here. Phi equal to minus of tan inverse mod of y by x. Y is equal to what? Y is equal to, you just compare and you will get y is equal to minus of 1 by omega c. Substitute. See, phi is equal to minus of tan inverse minus of 1 by omega c, and what is x? By comparing we can get x is equal to r. So phi is equal to minus of tan inverse mod of minus of 1 by omega c by r. So if you simplify, we will get phi is equal to minus of tan inverse of 1 by omega rc. Clear? Now see, if we calculate the current flowing through the circuit, we will get I equal to VI at an angle 0 degree by Z. That is, so let us assume that we are providing input voltage pure sinusoid. That is VI angle 0 we are applying. Clear? So I is equal to VI angle 0, that is no phase shift in the input voltage. So I is equal to VI angle 0 by mod of Z angle theta, because complex number Z is equal to mod of Z angle theta. Clear? Now we can simplify and get VI by mod of Z angle minus theta. So what is, angle minus phi. So what is phi? Phi is minus tan inverse 1 by omega c. Put here and we can get I is equal to VI by mod Z at an angle tan inverse of 1 by omega RC. Clear? Now see, we got the expression of the current as this one, I equal to Vi by mod Z at an angle tan inverse 1 by omega RC. So what is V output? V output is voltage across this resistor R, that is I into R. So is equal to Vi by mod Z into R into at an angle tan inverse of 1 by omega RC. So we can say that output voltage leads angle tan inverse 1 by omega RC than input voltage. That means output voltage leads than input voltage. So let us now assume that this is 60 degree. Okay, we can make this 60 degree easily because 1 by omega RC equal to tan 60 degree. Then we can choose omega is that frequency in which we want to oscillate. R we can choose properly and we can calculate the C value. So we can clearly make such a circuit for which tan inverse 1 by omega RC equal to 60 degree. That means output will be 60 degree. Output will lead 60 degree than input, or in other words we can say input will be lagged by with compared to the output in 60 degree factor. Okay, so this RC combination, if we connect C and R and if we take the output across R, we can make 60 degree lagging of input with respect to output, or 60 degree leading of output with respect to input by proper design. So what we do, we connect three similar circuits in this fashion, series like back to back we connect. Then see here in this node the output is leading with respect to input in terms of 60 degree factor, then here another 60 degree, then here another 60 degree. So 60 plus 60 plus 60 is 180. So if we apply input as this one, we can get 180 degree phase shifted output. So this is our logic why we use this RC combination back to back connected RC circuit in the RC phase shift oscillator, that is just to get 180 degree phase shift. So that's see here basically input is now 0 degree. If this is inverting amplifier, 180 degree phase shift will be there. Now see here one more 60 degree phase shift will be there by the RC combination if we adjust the circuit in such a way that tan inverse 1 by omega RC equal to 60 degree. So now a 180 degree plus 60 degree, it will be 240. Then another 60 degree phase shift will be there. So 240 plus 60 is 300. Then another phase shift is there. So 300 plus 60 is 360. So see, input we started here, output is 180 degree phase shifted. Again after 180 degree phase shift we get the same input. Okay, and it is again input of the basic amplifier block. So basically if we make one complete loop rotation, how much phase shift we are getting? See 0 degree and here also in same phase. This signal and this signal are in same phase. So after complete rotation we are getting 360 degree phase shift. So in such a way we can satisfy both the Barkhausen criteria, that is in terms of magnitude and in terms of phase. So just this is basic feedback network which can be used in phase shift oscillator. If you want to know the practical application, I will discuss in detail in my next videos. See, this is normal CE amplifier. Clear? Whatever input we are giving, suppose see here I have given input in such a way we are getting 180 degree phase shifted output. Then we take what we are taking, see here we are connecting one node here. We take the portion of the output voltage and we give, this is the feedback network, we supply the same output voltage in the feedback network. See, output voltage, this is output voltage now. So with respect to input here 180 degree phase shift is there, then by this block 60 degree, then 120 degree, then 180 degree phase shift. So total by this block another 180 degree phase shift will be provided, so that this output will become 180 degree phase shifted and it become input. Okay, and obviously it is clear to satisfy the magnitude condition of the Barkhausen criteria, the magnitude of gain of this C amplifier should be equal to 1 by magnitude of the transfer function of this feedback network in the oscillation frequency. Okay, so this is how This is the basic concept of phase shift oscillator. This is all for my this video. In my next video I will continue. Thank you for watching.